of a JK flip-flop, right? So a JK flip-flop is built from an SR latch. So let's build this one using NAND gates. So we're basically just building our SR latch first. So the input is coupled to the output. So this is basically our S, then this is our R, then this will be our Q, and then this will be our Q naught. So we take this, we couple it to a NAND gate. Even here. This is basically our clock. We should have a clock. Then we need to take this input and couple it to this output. Couple it there. And then we also need to take this one. This output and connect it to this input. Then this will be our J. And then this will be our K. So before we start with the truth table, right, we need to check the operation of a NAND gate first. It's simpler to work that way, right? So now let's see. So if you have 0 and a 0 in a 2-input NAND gate, right? In an AND gate, the output will be 0. In a NAND gate, the output will be 1. If you have 0 and a 1, in an AND gate, the output will be 0. So in an AND, it will be 1. 1 and 0. AND gate, the output will be 0. NAND, the output will be 1. 1 and a 1. NAND, and the output will be 1. NAND, the output is 0, right? So we're going to use this. So what do we have? So we're going to have J. We're going to have J. Let's just increase the font a bit. We're going to have J. Then we're going to have K. Then we can have Q. Then we can have Q naught. Then the comment, right? Great stuff. So let's start with J and K being 0, 0. 0, 0, right? Okay. So let's start our starting position with Q being 0 and Q naught being 1, right? So the clock, let's bring it high. So the clock is 1 here. And here the clock is 1. We also need a clock here. Clock. So the clock is high. Right, okay. So let's go red again. So the clock is high, so it means it's 1, 1. Then our J and K is 0, so this is 0 and 0, all right? Then the output here this is 1, and then this is 0, right? So because there's a 0, right, we know S will be 1, right? And here, because there's a 0 in an AND gate, R will be 1, right? Then a 1 and a 1 will give us a 0, and then 0 and a 1, because will give us a 1, right? So do you see that we started with this input of 0, 1, we're still getting the same input 0, 1. So what it basically means is that if both J and K are low, right, then even if we apply and then we apply the clock signal, right, it means that there will be no change here. So Q will always be 0 and Q naught will be high, right? So that's why they say no change. So this is Q, this will be Q, and then this will be Q naught, right? Then we say no change. So the state doesn't change. This light is off, this one is on. So it will just be like that. It will be like that. All right, now let's check 0, 1. So assume from there we go to 0, 1, right? Let's see what happens. Okay, the clock should always be there. All right, so the clock will always be high, right? So that's why the clock is 1 here. Then we take this input, which was a 1, put it here. Then this input, which was a 0, we put it here. Then our J is 0. Then our K is 1, right? Our K is 1. So this we call reset, but let's see what happens here. So if you have a 0, we know your output will be 1, right? From this in an AND gate. Then if you have a 0, the output will still be 1, right? So you have 1, 1, right? So from 1, 1, the output here was a 0. If you have a 0 and a 1, the output will be 1, right? Then if you have a 1 here, 1 and a 1, the output will be 0. This 0 here, the output will be 1, right? So what do we have here? 0, yeah. So we have Q, our Q becomes 0, right? And then our Q naught becomes 1. We call this reset. So when you set K, when you switch K on, right? Q naught, the LED, you have two LEDs here, the Q and the Q naught. The Q naught one becomes on, then the Q1 becomes off, right? So we call this reset. Reset. Okay, great stuff. Now, let's see what happens when we set J to 1 and then K to 0. All right, so Q was 0, so 0 will be here, and then Q naught was 1, so 1 will be here. Then J, this time it's 1, and then K, this time is 0. So 1, 1, 1, we know everything 1 gives us a 0. If there is a 0, the output will be 1, right? We know if there is a 0, the output will be 1. So we don't even need to check what is this, right? So a 1 and a 1, 1 and a 1 will give us a 0. 0 and a 0, just because there's a 0, it will always be 1. So now our output has changed, right? Q is now 1, and then Q naught is 0. So Q is now 1, then Q naught is 0. So we call this state reset. Set, I mean, so we were setting Q. Set Q, set, right? So the last combination, it's basically 1, 1. What happens if both J and K are high, right? So this state, we call it toggle. So let's see, why do we call it toggle? All right. So here's your 1. Show 1 here, your 0 here, J it's 1, and K it's 1, right? So because there is a 0, we know the output will be 1, right? Because there is a 1, we know the output will be 0. Everything is 1, the output will be 0. So because there's a 0 here, we know the output will be 1, right? Then this one, we take it here, 1, 1. 1, 1 will give us a 0. As 0, 0, obviously it's a 1. So now do you see this changed? So now we have, you must check properly. So we have 0 now. Let me use a different color. Now we have 0, right? And then we have 1, right? This is basically 0, and then this is 1. So we take this Q, we bring it here. Now we're feeding it a 0 here, right? And then here, we're gonna feed it a 1. So let's see what happens when you do that. So this is a 1, 1, 1, 1. We know if everything is a 1, the output is 0, right? Then if there is a 0, the output will be 1. So here we have a 1. Because we have a 0, we know if there's a 0, this output will always be 1. So this is a 1. Then we take this one, we bring it here. 1 and a 1 is going to give us a 0. 0, because there's a 0 here, it will always be 1. So Q now is 1 and Q naught is 0. So Q now is 1, Q naught is 0. All right. So now we have 1 and 0, right? Now, again, we can feed the 1 and 0 back, right? We can make this 1, then we can make this 0. It's just going to toggle. Now it's going to be 0, 1 again. You get my point? Then here it's going to be 1, 0 again. So it will always toggle like that. It will just keep toggling. So we call this state toggle. Let me do this. So this will be Q. And then this will be Q naught, right? Then we call the state toggle. Right. Can you just verify if it's according to, all right, Q naught, and then there's Q0. Okay. Q naught. Yeah. Yeah. All right. Yes. Okay. So what we are just saying here is that, okay, here, check here. Here there's no change because Q remains Q. Q naught remains Q naught. So here Q becomes Q naught, right? It's always changing state. Like if Q, yeah, it toggles, so it changes between the two states. So this this Q, the second time around, it goes to 0. So that's why here it's complemented, right? And then Q naught, let me use green there. Then Q naught becomes a Q. Do you understand? So if Q was 0, right, this one becomes a 1. Then if Q naught is 0, Q becomes a 1. So it toggles, it switches between the states, right? So this one, if Q is 1, Q remains 1. If Q is 0, Q remains 0. If Q was 1, Q remains 1. So that's why we say no change. Here we say toggle. So this is basically the basic operation of a JK flip-flop. Thank you.